Alright, welcome back to Underground Science, and in this video we're going to be basically talking how to name alkanes, but specifically cyclic alkanes. So I think we've talked about just like the intro to cyclic alkanes in previous videos, but like if we just go over real quick, right, if we start from the beginning and write down methane, which we know is just a CH3 group. If we're talking about a branch from a parent chain, we'd be talking about a methyl branch, right? So this would be a methyl branch. If we're talking like that, there's not really a ring you can make with one carbon, right? Or even two carbons. If we're talking about ethane, right, just a two carbon chain here, you can't really make a ring with that. So the least number of carbons you can make a ring with would be propane. Like if we talked about propane, that consists of a three carbon chain, you can make this into a triangle, right? So if we talked about cyclic alkanes, and we started by talking about propane, right? So propane would be, that's not cyclic, but if we said cyclopropane, right, then we have a cyclic compound that's an alkane, but in cyclic form, which is like this. Same thing, we can say, instead of saying butane, we can say cyclobutane, which would be a four carbon structure, but it would be an alkane, a cyclic alkane. Okay, so let's draw that a little bit neater. So we would have a cyclic alkane like so. And then we can move on and say, and talk about cyclopentane the same way, right? Since it's cyclo, it would be a ring form of pentane, which would just be a five carbon structure like this. And then last but not least, if we're talking about a cyclohexane, right, that would also be in a ring format because it's cyclo, and it would look like this. So those are the common rings, cyclic alkanes that we should know. And let's try to name a few by going through some examples. So if we start off basic, right, like if we did this, if I drew this, right, or if I drew something like this, right, what would that be? What would these compounds be named as? So first things first, right, if we're just looking at this, what's the main part of this molecule? The main part, the parent you could say, is the actual ring itself, right, for both these examples. What's the substituent? The substituent is this, right? So if we're taking this example first, right here, what would be the name for this? Well, we know that the ring is called what? It's a five carbon ring, and so it's a cyclic alkane, but specifically, what is it called? A cyclopentane, right? So we know we have a cyclopentane here, and what's a two carbon substituent called, like it's presented here? What would be a two carbon substituent called like it's presented here? That would be an ethyl substituent, right? So that's all you have here. You only have a cyclopentane ring and an ethyl substituent. So you just join those two words together, and the final name would be ethyl cyclopentane. Ethyl cyclopentane. Right? So that's not that bad. Now that we know that, we can name this easily. So what do we have here? We have a cyclohexane, right, ring, and then on that we have a substituent that's a one carbon substituent, so it's a methyl substituent. So what would the name be? You just join it together. So that'd be a methyl, right, methyl cyclohexane. All right, so these are just basic examples, just to start off with, right? So let's talk about another one. So let's say we have another cyclohexane ring, right? And on this, let's put a substituent here and a substituent here, right? So like if we name the parent chain, you could say, right, would be this, and the substituents would be this and this, right? But if we take note of what happened previously, we only had two things to worry about: a substituent and the parent molecule, right? Substituent, parent molecule. So we just joined those two together. We didn't have to number it. I mean, you could have said here, you could have said that this is a 1-methyl cyclohexane, right? But why would you say that? Like, of course, it's kind of already said that it's on the one carbon. You don't have to number this 1, 2, 3, 4, 5, 6, right? Because there's only one methyl substituent. But here we have two substituents, so we have to number it now. So if we go back and number it real quick, right, there would be two ways that we could number it. two, I mean, there's many ways we can number the string, but there would be two ways that we should only look at in order to get the right answer or right numbering pattern. So what I'm going to do to find that out, right, is I'm going to draw it twice for us so we can see both the ways clearly. Okay, so let's number the left one first. And if we started, whenever we have more than one substituent on a cyclo, in this case on this cyclohexane ring, the method we should use is we should start by the number one, obviously, but we should start with the number one on each of the substituents. So what I mean by that is, first in this one, right, let's go here, 1, 2, 3, 4, 5, 6, right? And then actually what we should do is draw it 4 times. So, and the reason for this is because you can name it, you can go counterclockwise and clockwise. So if we just drew this again, right, and did this, we can also start, so we start here, right, but this time let's go this way, 1, 2, 3, 4, 5, 6. Now let's switch over to this side, right, over here. So let's draw a line of separation. And if we do the same thing here, except we start numbering on this carbon, because that's a different substituent, right? So we do 1, and choose whichever way you want to go, because we'll do it again. 1, 2, 3, 4, 5, 6. And then if we draw it again to see the other way, right, that's an ugly drawing. And let's go ahead and draw this substituent right here and this substituent right here. Same thing, we start number 1 on this carbon because it's a different substituent, and then we go the other way, right? And I mean, obviously, if you're doing it in real life or in an exam, you wouldn't do all this. It's just to understand it. After you understand it this way, you can easily identify the longest carbon pattern, right, numbering pattern, or the correct longest carbon numbering pattern pretty quick, right? So we have these 4 options. So let's go on the left side, right? So if we started here, at what carbon numbers do we have substituents for the top one? So I'm over here right now. So we have substituents at carbon numbers 1 and 3, right? What about for the drawing below this? So right here, we have substituents on carbon numbers 1 and 5, right? Let's go to the right side. Right here, at what carbon numbers do we have substituents on? Carbon numbers 1 and carbon number 3. What about for the one below that? So right here, we have substituents on carbon number 1 and carbon number 5, right? So if we see, okay, what's the best way to number this? The best way to number it is choose the numbering pattern in which the carbon numbers, the least carbon numbers, contain the substituents. So in other words, choose the numbering pattern in which the substituents are on the least carbon numbers, right? That's a better way to say it. So here, which one would we choose? Right away we can eliminate these two, right? Why? Because 1 and 5 is greater than 1 and 3, and we need the least numbers pattern. So 1 and 3 wins. Now, who do we choose between these two? Well, let's see, right? So if we look at this one right here, the number 1 carbon has what? As a methyl, right? So this is a methyl. And what about the number 3 carbon? That's a propyl. Now let's go over to this side, right here. The number 1 carbon has a propyl, and the number 3 carbon has a methyl. Okay? So which numbering pattern do we choose? If this situation comes upon us, right, now we choose the numbering pattern in which the substituent that comes alphabetically first is on the least carbon number. So if we're looking at this example right here, methyl M comes before P alphabetically, right? And on top of that, the M is on the least carbon number because 1 is less than 3. If we look on the right side, it's the opposite case, right? So the methyl is actually the one that comes alphabetically first, but that's on the higher number carbon, which is 3 as compared to 1. So the winner, right, of the numbering pattern would be this one. Okay, so if we just took that into consideration, so let's erase everything else and just focus on this numbering pattern and drawing. All right, so if we're focusing on this numbering pattern now because of the reasons we stated, right, just before this, now it's going to be pretty easy. So now that we have our substituents known and our parent cyclic alkane known, we can name the molecule. So on the 1 carbon, we have a methyl, so we have a 1-methyl, right? And on the 3rd carbon, we have a propyl, so we have a 3-propyl. And we have a ring that's 6 carbons long, so it would be a cyclohexane ring. So if we put all of this together alphabetically, right, we have to focus on that, because if we don't put alphabetically, we're going to get this problem wrong. So alphabetically, everything together, if we put this, it would be 1-methyl, right, 3-propyl, and the last one would be cyclohexane. Okay, and remember this is a methyl group, so let's spell that correctly. All right, there you go. All right, so that's for this example. Now let's do another example. So if we took, let's say this time we weren't working with a cyclohexane, right? And let's just do one there and another one here, okay? Now, seeing this right away, what do we need to do first? Because now there's more than one substituent, right? I mean, like, actually first, if we just wanted to name this would be easy. There's only one substituent, so you don't have to name it. You don't have to number the carbons, right? You can just say the substituent name and the ring name and join those together. So what I mean by that is you have only one substituent, which is bromine, and only one parent ring, which is a cyclopentane ring because it's 5 carbons, right? So let's write that down. What do we have? We have a bromine, right? But that's a substituent, so we would be bromo in the name. And we have a ring that's 5 carbons, so we have a cyclopentane ring. And so if we just join those together, that's the name. So we have a bromo cyclopentane molecule. That's it, right? But what if we add more than one halogen on it? So what if we had a pentane or cyclopentane, right, ring, and in this cyclopentane ring we put a bromine here and a chlorine here. All right, so let's go and do what we did last time and try to number this. So last time we divided it into 4 because we have 4 main ways that we can number this, right, including clockwise and counterclockwise. So if we just go ahead and draw this again, but we split this, right, into 2 sides, and let's do 4 right like that, and then so 1, right, would be right here, and I'll actually draw it in and come back to it. All right, so here we are. So let's start numbering this. So let's start on the top left, right, and let's start at bromo, or bromine. Let's start at the bromine substituent, which is bromo, right? So 1, 2, 3, 4, 5, right? And that's it, because it's only a 5 carbon ring. Let's go below that and let's just go the other way. So we have 1, 2, 3, 4, 5. And then let's go to the top right, and now let's start at chlorine. So 1, 2, 3, 4, 5, and let's go the other way. 1, 2, sorry about that, 2, 3, 4, 5. All right, so now let's compare the numbering pattern on each one. Okay, so let's go to the top left again, so we're over here, and let's compare the left side. So when we started in the top left, we started and over here, right, on this carbon, and then we went clockwise. And here we started this carbon and we went counterclockwise. So if we look at this numbering, so I'm still talking about the top left side, on what carbon numbers do we have substituents? So that would be carbon number 1 and carbon number 3, right? If we go here, on what carbon numbers do we have substituents? That would be carbon number 1 and carbon number 4. So out of these two, right, out of this one and this one, what numbers are overall less, right? 3 plus 1, if you can even add these together. So 3 plus 1 would be 4, and 4 plus 1 would be 5. So that means this wins, because we're always wanting the least carbon numbers for the substituents to be on. So that one wins. So we can cross off this, right? So that's done. And now let's compare the right side. So the right side, we started numbering at the chlorine. So if we're looking at the top right, what carbon numbers have substituents on them? So we would have carbon number 1 that has a chlorine substituent and carbon number 4 that has a bromine substituent. So we'd call it chloro and bromo respectively. And if we're looking at the bottom right, what carbon numbers have substituents on them? So it'd be carbon number 1, carbon number 3, right? So again, 1 plus 3 is 4, 1 plus 4 is 5, so the top right loses because we always want the least. So we're going to get rid of that, and this wins. Now we're comparing the winners. So we're comparing these two, okay? And so, because these two, we have a substituent on 1 and a substituent on 3, both the least numbers, right? Out of comparing to 1 and 4, right? Comparing to 1 and 4 here and here. So what do we choose now? Now we choose the least carbon number has to be on the alphabetical winner. So what I mean by that is, if you see in the top left, right, we have the least carbon number, which is 1, right, the first carbon, on bromine, and here we have the least carbon number 1 on chlorine. Who comes alphabetically first? Bromine. So we choose the top left numbering. So that means this loses also. So let's go and do the top left numbering on another page. All right, so the numbering that we decided that we were going to do was the least number would be on the alphabetically winner, or the alphabetical winner, which is bromine, because B comes before C, right? So we do 1, 2, 3, 4, and 5, right? Now that we have this, we can name the molecule. So what do we have, right? Let's write that out. So we have a 1-bromo, and we also have a 3-chloro group, or a substituent. And then overall, we have a cyclopentane ring, right? So we just join everything together, alphabetically though, so it can be correct, right? So what do we have? We have 1-bromo, 3-chloro, 3-chloro, cyclopentane. All right, so that's our name for this molecule above. And let's do one more example. All right, so let's do this example. Okay, so if we're looking at this, right, we want to start numbering it right away. So we'll do the same method we did last time. I know it's a little bit slow, but that really takes the process down into 4 individual levels, because we number it 4 ways, and we just completely choose the correct way to number it. So let's do that way. So if I've divided it up into 4, and let's start. So first, let's start at the isobutyl group and number it counterclockwise. Okay, and now let's start the isobutyl group and number it clockwise. 4, 5, 6, right? And then let's go to the right side, and let's start at the ethyl substituent and number it clockwise. Okay, and now let's start at the ethyl substituent and number it counterclockwise. 4, 5, 6. All right, so let's start at the top left. Let's compare the left side and then the right side. So starting at the top left, right, which carbon numbers have substituents on them? So that'd be carbon numbers 1 and carbon numbers 5, or carbon number 5. Let's go to the bottom left and do the same thing. So carbon number 1 and carbon number 3 has substituents on them. Substituents on them. And then let's go to the top right and do the same thing. So carbon number 5 has a substituent, carbon number 1 has a substituent, and then the last one right here, carbon number 3 has a substituent, and carbon number 1 has a substituent. So if we're just comparing the left side, who wins, right? What carbon numbers that have substituents on them, what are the least carbon numbers that have substituents on them? So to find that, you can just add these together. So what's 1 plus 5? 6, right? And what's 1 plus 3? 4. So who wins? 4. So that means we can get rid of this numbering. We're not going to use that. Let's go to the right side. Again, same thing. 1 plus 5 is 6. 1 plus 3 is 4. 4 wins because that's the least carbon numbering. And so this wins and this loses. And then now if we're comparing 1 and 3, 1 and 3, we can't really add it and compare because it's going to equal 4 for both of them. So now which one do we choose? Well, we look at who wins in an alphabetical manner, right? So if we look here, right, this 1 carbon, what is that? That's lower than 3, right? So that's the least carbon number. All right, well, what's the substituent on there? That's an isobutyl, right? Okay, and then if we look on the other side, who's the lower carbon here? 1, right? I mean, who's the lowest carbon that has a substituent is 1. So, and what is that substituent? That's an ethyl substituent. Who comes alphabetically first, isobutyl or ethyl? So this is where we should deviate just a little bit and talk about certain prefixes that you may have already heard. So for example, we're going to just for a little bit talk about di, tri, tetra, right? And what other common ones do we know? Sec, tert, what other prefixes are there? Iso, cyclo, right? So these ones for now, right? And so which prefix here counts alphabetically when naming compounds? The only ones you have to make sure of to pay attention when you start trying to see who comes alphabetically first are iso and cyclo, because these two prefixes, right? These prefixes count when you're talking about alphabetical order, when naming molecules, okay? So these count when you're talking about alphabetical order. So knowing this, let's go back, right? And so what does this mean? That all of these prefixes don't count. So if you, for example, if you had a dibromo, right, versus a let's say ethyl, right? If you had a dibromo versus ethyl, who comes first alphabetically in terms of naming organic compounds, right? It would be dibromo, because di, the prefix di, the D in there does not count alphabetically. So what you're actually comparing is B and E alphabetically. In this case, B comes before E, so you would actually put dibromo first, and then you would put ethyl second when you're naming a compound. All right. So, but if we said iso, let's say isopropyl versus ethyl, right? Who wins alphabetically now? Well, ethyl, so now iso counts, right? Because that's one of our prefixes that counts. So you're actually comparing the E in ethyl and the I in iso. And who comes first? E, right? Alphabetically. So you'd put ethyl first when naming a compound, and then isopropyl second when naming a compound. All right? So let's go ahead and finish this naming. So again, we said that the least carbon number on the left side is 1, and that has an isobutyl, and the least carbon number on the right side, which is 1, that has a substituent, which is ethyl. And who comes alphabetically first? Well, we now know that iso counts, and so we're comparing what? E and I. Well, who comes alphabetically first? E. So that means that we're going to choose this numbering pattern and not this one. So let's go ahead and write this, or take this molecule and write it on another page. All right, so we have a cyclohexane ring, an isobutyl substituent, and an ethyl substituent, and the numbering pattern we chose was the least carbon number would go in the alphabetical winner, which is ethyl in this case, as compared to isobutyl. So we would have 4, 5, and 6. And now, what do we have here? So we have a 3 isobutyl, and we have a 1 ethyl. So, and also we have a cyclohexane, right, as our main ring. So put all this together alphabetically. So remember, E comes before I. So we would write down 1 ethyl, 3 isobutyl, cyclohexane. All right, so that's pretty much the basics of naming cycloalkanes. I feel like if you can do these examples and have a good understanding of these, you can probably conquer a plethora of other cycloalkane naming problems. All right, and so in our next video, I'll probably start talking about alkenes and naming alkenes, and so I wish to see you guys there.